Welcome to the final exam, question number 38. And it says, the calculations for the design of a retaining wall show that the dead load resisting moment is 1.25 times the overturning moment from earth pressure. Select the most correct statement. And I designed retaining walls, and I'm going to explain what overturning pressure is. So there's a few things in retaining walls. Actually, sorry about this. This is a horrible sketch. I'm one of those people who hate horrible sketches and will always change it. Anyway, so here's your retaining wall. That's earth. And there's a few things you want to check on retaining wall. Before you check the capacity of this concrete, you want to check a few things. There's one thing that's called sliding, meaning since you're going to have a, sorry, let's change colors. You're going to have this this pressure wedge, and then you're going to have the active pressure wedge, and then you're going to have a resultant. And if that resultant is enough to push it, so for instance, the whole entire thing will go that way. I hope that makes sense, and that's called sliding. So you want to make sure it's not able to slide, and typically you'll take a look at this soil in front of there, and you also look at some friction down here on the soil, and if that doesn't do it, you can also put a shear key in, which is a little bit more concrete, and you'll put the reinforcing into that shear key as well. And that's probably not correct, but I'm just trying to show you how it's generally done. So you can have a shear key if the other forces aren't enough to make it slide. So that's sliding. You can also have overturning, which it's rotating. That means the whole thing rotates and it tips and it falls like that, and that's another failure. That's called overturning, and that's what we're looking for right now. And that's what we're looking for. So you have that active pressure pushing out, and then you also have this soil. It's the weight is on top of here. The soil is bearing down on the top of that, and that's going to create this. So you look at your moment. What is that moment? Times how many feet, and what is this moment? And as long as this moment is greater than this one by a certain factor of safety, then it will not overturn, as we say. So let's take a look at these sentences again. But I know, before I'm looking at sentences, I know that typically when I'm doing a design, I use 1.5, and this matters what you're looking at, but most of the time I see 1.5 factor safety for overturning. And it may be different depending on what type of code you're looking at, but this is pretty typical. So let's take a look at what these questions are. And it looks like they have A, B, C, D for answers. And we're looking for the most correct statement. It says the design is adequate. I would disagree, because I said 1.5 and 1.25 factor safety is too little. So I would say no, the design is not adequate. It says a key integral with the footing should be added. If you put a key right here, and it's integral, meaning it's part of it, so you put reinforcing in right there. Once again, I'm drawing it probably not correctly. You might put it down like that. It kind of is depending on the designer how you want to tie it in, but as long as that's tied in, and this might have a hook on it so it develops that reinforcing. Actually, real quick, I'm going to go over to development. Basically, development means that reinforcing part needs to be enough into the concrete to hold on to it, or it'll pull out. Let's say you have a piece of concrete, and let's say you have a stem up here, and you pour the footing first. Let's say you pour that footing first, and you have a piece of reinforcing just coming up an inch or two. Because let's say it's a really short wall, and heck, you don't need a lot of reinforcing because it doesn't need it. But this, let's say it's only at 2 inches, which is next to nothing, and I'm going to tell you right now that's never going to fly. And what will happen is it will slide right out of that. It will slide out of there because it doesn't have enough grip. You know, that reinforcing kind of looks like this, and these are raised. So it kind of grabs that concrete. And depending on the bar size, larger bars will need more development length, but you need to bring that bar all the way up here so that it grabs enough concrete so it won't pull out. Alright, so that's what development length is. And it says a key integral, I'm back to it. I hope that wasn't too much of a distraction. But going back, it says a key integral with the footing should be added. And that's the key. The key is this down here. And as we said before, that's for sliding. If you have rotation, I don't see, it may be very, very minimal. You could count and say, hey, if this is going that way, that means that key has this soil right here that it has to go through, and therefore you can count on the passiveness of this soil. And that should give you a little bit of, let's change colors so you actually see what I'm thinking. You would have a passive block right here, and that would counteract that movement. And you'd be right, but that's not the best way to do that. That's for sliding. This key right here is for sliding, so I'm going to say that is incorrect. You could justify it, but it's not the reason you do it. It's a very big stretch. All right, moving right along. The next one, it says the footing should be made wider. Well, what would that do? Let's say we made this wider. First of all, that would give us more soil right here. It would stretch out that moment arm to about right there. So that would be good. That would give us more soil, would mean a larger load. It would give us more moment arm. It would pretty much, it would go from here to here, which is good. The active wedge and our active right there is still the same. So that only helps us. So that's a good thing. Yeah, that would work well. Let's just circle it. That's a very good answer. That's number one thing that you'd probably want to do. Definitely want to do. I'll go ahead and tell you that is the correct answer. I'm assuming because it's a very good answer. Let's go on to D though and make sure that's not a better answer. The amount of reinforcing steel should be increased. And like I said before, let's say you put, let's say number 10 bars in here. Oh, that's not going to do anything. You still are going to flip over. And yeah, that reinforcing is going to make the capacity of this concrete more, but the capacity is fine. The whole thing's going to flip over, and that's what overturning is all about. So that's definitely incorrect. So once again, our answer is C, like we thought it would be.